told you, so you have to understand the probability first. Then you have to understand the conditional probability. Here we are going to do the Bayes theorem. Now Bayes theorem and naive formula will be same, guys. But the only difference is when we go with the naive, we are going to talk in terms of independent and dependent variables. That's it. Okay. So let's see this one, how it will work it out. So what is the probability, guys? Okay. The probability you want to define it as, it is the chances of happening a particular event. This is the probability of happening a particular event. Now, if you take it, a simple example, if I am having a box over here, just take it as box over here. Now, in this, I am having a circle. I am having a triangle over here, circle and a triangle. Now, if I pick it from here, how many are there? 2 are there. If I want to pick up a circle over here, I want to pick up one item, any one item I want to pick up. What is the probability that I will get a circle? So it will be probability of circle is, how many circles are there? 1. How many total items are there? 2. So the probability will be 2 over here. Now this is how you will calculate the probability. Now, if I have it 3 over here, 3 or 4, something like the different ones are there. Now one is circle, one is the square, one is the triangle, one is the star. Okay. Now what is the probability of getting a star, guys? How many stars are there? Only 1. Total number of 4, 1 by 4. So this is how you will calculate the, a probability. Now, what is the conditional probability? Conditional probability is you are calculating a probability when an event is already happened. First, an event will be already happened. If that event is happened, then what is the probability of happening the other event? That is what we will hear. Now, for a simple example, if there are 2 stations are there here, this is a station A and this is a station B. Now, and a train is coming out of this place. This place, the train is coming out. Now, when you are known that it is now, from here the train is coming out. Just take it. I will remove it. Okay. Now, what I'll say that now train is already crossed the station B. That is one of the condition is happened. So when the train is, done with the conditional B, that is, it is already crossed. Now, what is the chances that it will be reaching on time? So when you will be calculating this one, when it will be reaching on time, when the train is already crossed the station B. So how you will give it this one is, what is the probability of reaching the station A when B is already given? This is not called as by, that is called as B is already given or B is already happened. Okay. So this is probability of A by B, it will call it as. Okay. So this is called as probability of conditional probability. Usually whenever there is a conditional probability, guys, it is a standard formula. It is understood that now if I am giving it as P A by B over here, this is nothing but probability of A intersection B by B over here. Like this will be. Okay, this is the standard formula. You should understand it. Now, if it is P X by Y, then what it will be? P of X intersection Y divided by P of Y over here. Okay, something like this. This is a very much standardized one. Let's take one more example, guys, over here. Then we will get a clear idea. Now there is here, we took it one box over here. There is another box over here. Now here I am having a star and here I am having a square. And there is a 1 star over here and 1 square over here. Now I want to, first condition is, if I pick up 2 at a time, I should get at least 1 star. at least 1 star I have to get it. So if you take it, first condition is at least 1 star I have to get it. So what are the possible combinations I will get it if I pick it? One is I may get the star and star, first combination. Second combination is star and a square. Then next one is square and star. Okay. Third is square and square. Last is square and square. Now see this. How many possible outputs I can get it? 4. And what is the chances of getting at least 1 star? 3 are the chances of getting at least 1 star. This is I'm taking the first condition which has to be happen, like crossing the train from the B. This is the first condition which has to be happen. Now that is 3 by 4. Now what I'm saying, when at least when we pick up 2 at a time, at least 1 star if we get it, in that, what is the chance of getting 2 stars? So one condition is already happened. What is the condition happened? We took the 1 star. We took it at least 1 star. How many times we got it? 3 times, right? Out of 4. In this 3, what is the chance of happening 2 stars at a time? So you will be getting it as something like this. If this condition means how many are there? SS, S square, okay, star square and square star. These are the conditions should already happen. In this, what is the chance of getting a 2 stars? 1 by 3. This is how you are going to get it. Now this can be also be written as, this is nothing but, you can write it as totally probability of A by B is equals to, is that probability of A intersection B and probability of B. Now probability of A intersection B is nothing but 1 by 3. Okay. Now actually it is nothing but if you take it, this is totally you will get it as 1 by 3. How you are going to get it is probability of getting only A is 1 by 4, right? Probability of getting only 2 SS means 1 by 4. In this totally, in this, if I want to get it probability of A, guys, what are the chances of getting or double SS over here? When I take it all, this is 1 by 4. And what is the probability of happening the B? Probability of B is 3 by 4. Now this is 1 by 4 into 4 by 3. This and this will get cancelled. We will get it 1 by 3. That is what we got it over here when we are doing it mathematically. This is the way we have done it with the geometrical one. This is the mathematical one. You will be getting 1 by 3. So now observe this one, guys. Probability of A by B is equals to probability of A intersection B by probability of B, right? Now this is the normal conditional probability. We know this. Now I want to derive the Bayes theorem from this conditional probability. Now this is a normal conditional probability. Now I can also write this one as, if I am having, when what is the probability of happening the B event when already A is given, then what will be the formula will be? Okay. Now if you take this one over here, what will come down? Probability of A by B into probability of B is equals to probability of A intersection B. Now this one will become probability of B by A into probability of A is equals to, okay guys. Now is this B intersection A and A intersection B is same? Is it? That is same. If you take it, if there is a two intersection points over here, just take it. This is my A and this is my B. Here I am having 1, 2, 3, AB. And here like X, Y, Z, AB. Now A value is 1, 2, 3, AB. B value is X, Y, Z, AB. Now if I am giving A intersection B, how much you are going to get it? AB. Okay. Now B intersection A is equals to what? AB only. So the both are same. So if these two are same, then I can directly equate to these two, right? I can directly equate to these two. So I can give it something like this. If you check it out, probability of A by B, sorry, A when B is given into probability of B is equals to probability of B when A is given into probability of A. Now, if you take this one down, what are you going to get it, guys? This is nothing but the Bayes theorem. If I do it, that is what you are going to get it. Probability of A by B is equals to probability of B by A into probability of A divided by probability of B. Now, this is nothing but your Bayes theorem. If you check it out, this is the Bayes theorem. Here it is. Now, in this, you can see this. A comma B are the events which are happening. When A and B is given is probability of A given B is true. Is when the event B is already happened. Now, this one is probability of B when A is happening. Probability of A and probability B are independent variables. Okay. Now, this is a normal Bayes theorem. Okay, Bayes theorem. Now, Bayes theorem, when you connect it to the navie algorithm. Now, algorithm, whenever we are going to deal with the algorithm in the machine learning, what are the variables we will be having? What are the type of variables we will be having in our machine learning? Independent variable and dependent variable. So here, you take it over here, probability of A by B, okay, given B, when probability of B given A into probability of A by probability of B. Now you take it A as dependent and B is equals to independent. Okay, guys? So here, see, this is the probability of A and B. Now, in this case, how we will give the dependent variable? How will indicate the dependent variable? Y. And how we will indicate the independent variable? X. So always the dependent variable will be Y and always the independent variable will be X. But how many dependent variables will be there? 1. How many independence variable will be there? N number. So Y will be Y only, whereas X will be Xi to Xn. Here, Xi to Xn. Now just replace this one with X and Y. Okay. Now probability of Y by Xi to Xn. Okay, guys. This is my left side. Now right hand side will become probability of, let me take it a bit smaller, probability of Xi to Xn by pi into probability of Y divided by probability of Xi to Xn. Clear, guys? Now this can be written as in the probability of xi by y into probability of x1 x2 by y into probability of x3 by y, and this can go up to probability of xn by y. Okay, this all should be multiplied by probability of y divided by probability of xi to the xn. Okay, guys. Now, if you take it directly, this is probability of y by xi to the xn, that is equal. So this is now how we can write it is, now you see this. If you are having something like this, guys, x1 plus x2 plus x3 so on till xn, how we can write this one? Summation of xi, that is where I is going from 1 to n, right? Now this, when you're doing the multiplication, is x1 into x2 into x3, you can write it as pi xi, where I is leading from n1 to n. Okay, this is the way you will be writing it. So if you take this one, okay, if you take it this one, we can write it as probability of y, this one I'm taking first, and pi into probability of xi by y, where I is equals to n. This is again divided by this one, that is probability of xi and xn. Now, if you take this one as a constant, usually there will be a constant value. So you can directly say that the p by y xi to xn is directly proportional to this part, right? If you take this one is constant, you can say that it is directly proportional to this part. So in order to get the maximum best of the value over here, then we can use the augmax function over here. We can use the augmax function. Now this is what it is. Now you see this. Probability of y, here y is considered as c. Now xi to xn. Now pi, when x p of xj, j is from the 1 to n, that is what we did it from 1 to n, where probability of xj by c it is, not I, c it is. Okay. Now here this is a constant, we took it already in the front over here, divided by this one. Okay. Now this is usually we will take it as a constant, guys. This we will take it as a constant. When we take it as a constant, you can directly say this one as probability of y by xi to xn is directly proportional to p of y pi, now product of xi by y, where I is equals to 1 to n. This is the way you can equate your Navier equation. Now this can be further say that to get the augmax. I think that I have it an augmax over here. No, I didn't get it. So there will be an augmax, you can get it. Now from this, you want to get the best of the maximum value, we will use a function called as augmax. So this can be applied with the augmax over here. Now usually this is the Navier algorithm with independent value x and dependent value y. When you apply, you will be getting this. So we have started with what is the probability. Then we have done it with the conditional probability, and we from the conditional probability we have derived the Bayes theorem. From the Bayes theorem itself is a Navier. but only difference is Bayes theorem. We are going to take it A and B, only one events. But in this case, we are going to take the complete dependent and the independent variables. So when you replace with the independent and dependent variable, the whole equation will be coming down like this. Okay. Now you can give it as like this. This one, I'm taking A as an dependent variable. Usually we will take it as Y. B as an independent variable, we take it as X. Now X will be usually will be one variable. We will have the multiple variables. So I have taken from the Xi to Xn over here. That's what I replaced it, guys. That's it. Nothing else I did it. Then I did the simple solvation of this problem. Now you see probability of here in the place of A, B, I gave it Xi to Xn by Y into probability of Y by probability of X to N, Xi to N. Now this I split it up where I applied the product over here. This is nothing but this one. Okay. Then the denominator is this as it is. This one went to the starting. When you take the denominator as constant, you can directly say that this one is directly proportional to this one. So in order to get the maximum, the best maximum value from this, there are multiple products, we are multiplying it. To get the best of the value from this, we will use the argmax function. Okay. Now this is just for your understanding. No one will ask you to derive the formula. Okay. Just for your understanding. They may ask you like this and all those things. Now you got the idea about the navie. See, navie can be implemented in the three different ways. Okay. The three different ways is, one is called as Bernoulli. Okay. Bernoulli navie. Second one is called as Gaussian navie. Third one is called as multinomial navie. Okay. So what is the Bernoulli? So whenever we have seen the Bernoulli in when we are dealing with the distributions, so Bernoulli means when there are two outputs are there, only two. When there is two outputs are there, then we will use the Bernoulli. Like for example, the example we can say it as Titanic. Okay, in the Titanic, either the person has survived or dead, not survived. What are these? Is there any middle which is there? No. Either he is survived or not survived. When you are dealing with such a problem, you are going to go with Bernoulli. Okay. Now, when we are dealing with the, a problem with a regression problem. What is a regression problem? When we are getting a continuous numerical value. When there is a continuous numerical value, then we will go with the Gaussian navie. Okay. See here, it is saying that continuous value, when there is a continuous value. Examples, guys. Stock price, car price, gold price, house price. This all comes under the category of this. For this, we are going to use the Gaussian navie. So it is again Bernoulli navie and Gaussian navie. Here you can see this Bernoulli navie and Gaussian navie. Okay, guys. Now, what is the multinomial? See, multinomial is nothing but where there is a multiple features are there. Very huge number of features are there. Then you are going to apply the multinomial navie. In this case, what you will do it is specially text classification. Okay. Now, before we have done any text classification, what do you mean by text classification? Text classification. Sir, hilana band karo. Socho thoda. What are the different types of problem statements, guys? What are the different types of problem statements we have seen? और क्या हुआ? प्रॉब्लम स्टेटमेंट नहीं मालूम, सुने नहीं अभी तक? One is the regression and classification. What is the regression problem? Continuous. What is classification? Discrete. Only discrete. Anything, it can be discrete, or like you can say it as ordinal, nominal, or discrete. Anything you can say. Now classification problem is to classify it. To classify. Classifying means making into different groups. Text classification. Have you done it? Text को कभी classify कर दिया हमें? You never did it. Encoding करे ना. Encoding is what? Text classification only. Text classification वही है ना, text encoding करे. So when you are doing this, so there is an encoding technique is there, like called as one hot encoding. What does this will do, guys? करता है ना ये? क्या करता है? क्या हुआ? हाँ? వినిపిస్తలేదు చెప్పు. What type of categorical data? Nominal categorical data. Categorical data to numerical data. So what type of data is called as nominal data? Which can't be ranked. Okay, which can't be ranked is called as nominal category. There is one more is called as ordinal encoding. What is this is used for? Ordinal categorical data. What is this ordinal categorical data is? पूरा बताओ. Which can be ranked? What can be ranked? वो कौन ऐड करेगा? So it is a data which can be ranked. Okay, guys, the data which can be ranked. Okay. Now the question is, what if now how many here? There will be, you will be giving only 0 or 1, right? You will give 0 and 1. Whichever there is there, 1 you will give it. Otherwise, you will give 0, right? Because all of them are 1. So in this, you will give it as 1, 2, 3, 4, right? 1, 2, 3, 4. That is for a limit. If there are 10 are there, you can give it 1, 2, 3, 4. What if there is a large amount of text is there? Very large amount, like very big text is there. Now again, stick to your fundamentals. What is the fundamental? Your model will never understand categorical data. It will never understand your categorical data. So how you are going to deal with it then? हाँ, वही तो करे ना. कौन सा अप्लाई करोगे? वन हॉट अप्लाई करोगे? लार्ज अमाउंट ऑफ डेटा दिए तो, like a page full of data is of maybe around 5,000 words. Then encoding कौन सा अप्लाई? वन हॉट, ऑर्डिनल. वही तो क्या करोगे बोल रहा हूँ, वो नहीं अप्लाई होगा. There is something called as vectorization. This is what is done in the NLP. What is that is called as vectorization. So this is again vectorizer or vectorization, they will call it as. Now when there is a very large volume of data is there, this will take care of it. Okay. Now whole of your NLP is based on this. Whole of your NLP is based on this. Now how it will work is, first it will split up the data. It will split up the data and rank them. Now remember that whatever may be the value of that, how much big the data is there, it will split up the data and rank them. Rank them means they will give the numbering. How you rank the ordinal data, the same way it will do it. It will take care of that and it will do it. Okay, it will do it. And after doing that, the next important thing is weightage. What do you mean by weightage? Weightage. What do you mean by weightage? हाँ? Type of ranking क्या होता है? Weightage क्या होता है? कितना प्रेफरेंस मिल रहा है? यहाँ पर आइचा, हाँ? So there is Babu. Imandi disturb just no. Mari, Ainan gal Nanu. Okay, see guys, first thing is understand this one. First is you will get the data. You are going to rank the data. Then you are going to give the weight to the data. Weight the data. That each and every data, how much it is weight in that. Now, for example, if I'm saying a simple example, I will say that like ticket, a word ticket. So what you can guess it, what I'm about to say about the ticket. Expect ticket, movie ticket. Huh? It's like, right? You can say the movie ticket or a gaming ticket or lottery ticket. Only some are there, right? That is what you have. Now there is one more called as hall ticket. वो कभी नहीं याद आएगा. You don't want it also. Huh? Hall ticket means automatically exam के बारे में. So look at that. So now you see this. I got a ticket. The name is I got a ticket. Now, submit. If I give it only got, and I am saying it, I'll give you a word got. I will say that guess what I am supposed to talk. You can't do that because there is not so much of weightage. In this, all of them, the most weightage is given to the ticket. Because by looking at the word itself, you will understand that that is you are doing something, right? That is what is called as a ticket. Now, this is the way the things are ranked. Okay. First, weightage. First, we are going to split data and give some numbering to that, the unique numbering, that is the ranking. And after that, we will give the weightage. Okay, we will give the weightage to that. I am in the class. Okay, I am in the class. Now, you see this. I am in the class. See, or I will give it as data science class. Which is the most weighted number word here? Most weighted. Data science class. Data science is the one which is more weighted. It is giving a perfect intimation that this is data science. Now you say that data science means, okay, you must be learning data science or you are working in data science. Class means kaun sa hai? What is a class? So here, first preference will be data science followed by the class. Now, if you leave this one also, maybe class or data science. If I give it in इसका मतलब क्या है? Is it necessary in the sentence? It is there. It should be there to complete the sentence. It should be there. Now, but what is the weightage of that? Least weightage. Very low weightage we have. Very least we have. I hope you got the weightage of this. Now, this is the second step you are going to do. Okay? You are going to first take the data. You are going to, give the numbering to the data. And then you are going to give the weightage to the data. Okay? Based on this weightage, you are going to predict now each and everything. You can predict it. What is that text? What is that text is all about? Now, if I am saying it, ticket, I said it. You guessed it. Ticket is having a weightage. You guessed it. Either it may be a lottery ticket or something like that. If I am saying mass, what is that I am talking about? You will take that I am talking about some planet, space, and something like that. So if I'm saying that maybe like temple, then what? It is a religious one. I'm talking about religious things where the God or prayers or all these things will be going on. So like this, based on few words, the whole sentence can be classified. So this is called, this is done over here in the news. One of the things what we did it over here was here. You see it? Classification news articles. It will be classified based on this weightage of the things. Like that, here is a spam detection is there. In whole of the email or whole of the message, there will be some weightages will be given to each and every word, which says that what is that message is all about. Now it is taking that discount. In whole of the message, they are saying that discount. These kind of things are a promotional messages usually. Discount, lottery, and offer. All these things are considered as a very weighted words, which will classify that whole sentence or whole mail, whether it is a spam mail or non-spam mail. Hope you got the idea of the weightage. So first, you are going to split the data. You are going to give the numbering to the data, and then you are going to do the weightage to that. Okay. This is the process of your text classification. So how to do that? Now the question is that how to do that? So here in the vectorization, there are two vectorizations majorly used. Okay. First one is called as, again, there is a whole process will be there, guys. Okay. Here the process is there. I'm going to explain you what is this process is all about. See, how it will be going on is, first, will be getting the data, guys. Okay. Then after that, next one, this data, I said it right, we'll get the data over here. And then we are going to do the vectorization. Then we are going to do the ranking of that one. Or weight. Ranking. And then after doing this, you are going to give this data to the model. You create a model first, create a model, and then feed this data to the model. Which data? This ranked data will be fed to the model over here. So feed the data. Then after that, you are going to give the output. That is score. So see this. First one, we will get the data, and then we are going to do the vectorization. Then we are going to rank it. Then we will create a model. To the model, we are going to get it, and we are going to feed the data, and then we are going to get it. Now, these two are very, very important things we are going to learn. These two are really important things we are going to learn. So now, if you take it here, I got some process. Now you can understand this. First one is, I said it like we are going to get data. That is input data. We will be importing the data. Next one is we are going to do the vectorization. That is called, that has been done by count vectorizer, or there is one more called as TF-IDF. This one more is called as TF-IDF vectorizer. These two are there. We are going to deal with the count vectorizer as of now to understand the process. So this will be kind of an advanced one, then it will take care of everything. You will not understand the internal mechanism, what is going on. So first thing is, we are going to do the count vectorization, guys, over here. Then I will do it as a TF-IDF. TF-IDF stands for term frequency, inverse document frequency. TF-IDF. Now you see, TF-IDF. This term frequency is TF, and IDF is inverse document frequency. Now, what is this purpose is, it will go through the complete data, whatever we have done it, whatever we are ranked it over here, and it will identify the weight, how frequently it is repeated, and what is the weight of that data. This is being given by this. It is nothing but this is IDF transformer. IDF transformer will do. Now, if I use it, now this is a two-step process. What is that? One is the count vectorizer. What this will do? It will split the data first, and it will give the numbering to the each, rank them each and every, not the rank, numbering to the each and every word, each and every word, it will give a rank. Then after that, now what is that IDF transformer will do is, this will transform the data and it will tell the weightage. It will give us the weightage to that. Now, after giving the weightage, now you will have the data over here. This is data is split up, and you give the proper weightage to the data. This one, you will take it and give it to model. Okay, hope you got the step. First one is you got the data. Then next step is you will split the data over here. Then afterwards, you will rank the data over here. Then after doing this, now your data is first split up. You are giving a numbering, and then you are going to give the ranking over here. That is the weightage. And then this is you give it to your navies. Okay. After this, now in the navies, we are going to use the multinomial. Okay. We will not use the Bernoulli or any other ones. So only multinomial. And after this, you will get the results. Okay. Now this is the whole process will be going. First one is count vectorization. Now let's do it a simple thing to understand this process. So you may ask me, what does this will do? Just like this one. Huh? No, it will do it both at a time. It will do the both at a time. So it will do the ranking as well as weighting of that, splitting and giving the numbering, and also the weightage will be taken care by the TF-IDF. TF-IDF vectorizer. Okay, I will write it TF-IDF rise. Okay, vectorizer. This is what it will do, the both, the combine the both, and it will do it. Okay, guys. Now this is how the things will be going on. Now, first thing is import the data. We imported data. We know that how to import the data. And then, or you create the data, it's up to you. Then we are going to do the count vectorization. Now, how you will get this count vectorizer? From sklearn, there is something called as feature extraction. Or there is something called as text. So this is feature extraction and dot text. From that, you will import count vectorizer. First, you imported it. Then you imported the class, guys. After doing this, what you are going to do it next? You will do it next. You imported a class. Huh? ठीक है, नेक्स्ट स्टेप क्या रहेगा? हाँ, ऑब्जेक्ट बनाना है. First thing is we will do it. cvec is the object. We will do it count vectorizer over here, and after that cvec dot fit what data whichever you want to give it. Usually we will give the training data. Okay, the training data, whatever X-train independent data. Then after that cvec dot transform. This you will get transformed data. Now you can see that the data will be split up first, and then you can see the ranking is also, numbering is also given to the data. Very clearly you can see that. After doing this, whatever the after transforming, we got some data, right? Data underscore CVEC, just take it. CVEC data, just transform data. This data, I'm going to pass it on to TF IDF transformer object as a fit to that. Got it? Now we have done it over here. Then we are going to go to the next one. sklearn dot feature extraction dot text import TF IDF transformer. What is the purpose of this one? Is it will transform the data with the rank. Okay, weightage. See. So I will create TF IDF is equals to TF IDF transformer. Okay. Transformer. And this one, what I will do is TF IDF is an object. Fit what? This data underscore CSV, you are going to fit it and transform it. Here, guys, you are going to fit it and transform. Hope you got the point now. First, you are going to split data and give the numbering to the data with the help of count vectorizer. And then we will pass that one to the transformer here. And then we will get the perfect data with ranked data. Now I will give that data name as, now I will give the transformer TF IDF transform. Underscore CVEC. Okay. Now this one I will give a name called as TF IDF data. This is the final data which you have to give it to your model. This is the one you have to give it to your model. Got it? Hope it is clear with you guys. Okay, this is the process you have to follow. Now see this, simple. We are having a data over here, normal data. Observe this one, we have the normal data. This data, we split it up using the vectorizer. What is the count vectorizer? I split it up. I give the ranking. Then I ranked this data. I did it by using the TF IDF transformer. First, this is the data. Then you ranked it. Then you transformed it. Okay. Now after this data, I'm going to feed it to my model. Okay, clear? Now, which data my model is tested? What form of data? Is this the original data or the transformed data? Transformed data. It knows only the transformed data, right? It don't know the original data. Now, if you want to test the model over here, if you want to test it, which data you will give it, the original data or transformed data? Why? So you have to transform your training data also, testing data also. Sure. Okay. Transform the testing data and we get it. Now we have done it. We got the prediction score like maybe 80% or 85%. Now I wanted do the prediction. I don't want the score. I want to do the prediction. So again, what data I will give it? Again, transform data or non-transform data? Transform data only. Clear? Got it, guys? So you have to do it. That transform data in a simple way. Now, if you are cooked a rice and you had it and you said that it is not good. Now next time I will show you another rice. Now tell me whether it is good or not, means what you will say. Let me cook and eat. Directly you eat and you'll say it. Okay? Whatever you transform the data, the same way you have to give the data to it. All the time you have to transform it. So your training data, you transform it and give it. So your testing data, you have to transform and you give it. And your prediction data, you have to transform and you have to give it. That is your. So again, doing transform multiple times. Instead of that, what you will do it, whatever data we are getting, we will send it to a function. It will automatically transform and give us the prediction. Okay. So that is that. Now hope you are clear, guys. Any questions? Now this is a very important steps which based on which whole of your NLP is based on. Whole of your NLP is based on. Now these steps are really very, very important. You will be seeing the same thing. You will be seeing the vectorization only over there. You will be seeing the TF IDF vectorization. Only two of them will be there. Either you use the count vectorizer or use the TF IDF vectorizer. So these are the very important things. Try to understand this. Hope it is clear. Use it. हाँ मैं यूज कर सकता हूँ लेकिन आपको कुछ समझ में नहीं आएगा इसलिए मैं ये पूरा कर रहा हूँ. You can use it. You can use it directly. You can use it. Only TF IDF use करके वो डेटा जो भी आता उसमें you can make it a pipeline also. I will show you. Make pipeline बोल के रहेगा. ये पूरा this is not, you are not going to do all this stuff. Just make it 2 pipelines. So like for example, I'm making it as a pipeline over here. I will write it as make pipeline. Inside this, I will give it the TF IDF vectorizer and I will give it multi-nominal, okay, navie. So what will happen? This will give me an object, model object, anything, model object. So for this, now you see this, what I did the first step over here, I fit the data, right? I fitted the data over here. We got the data and we fit the data over here. Some data we have to fit it. Then that data we will transform it. Then that data we are going to send it to, sorry, not here. Here we are going to send it. And then we are going to transform this. This is the process. Here, directly you send the data over here. That's it. This data will first go to this. It will split it up and it will transform it. Later on, it will send it to this one and your model will be ready. So a single step, it will be done. No need to do all this. But when you do this, then you don't understand the internal mechanism. Once you know the internal mechanism, then you can do anything, whatever you want. Not only this, you can build up multiple things and you can do it. Okay? So that is more important. This is the internal mechanism which you have to know. First, take the data, then send it to the count vectorizer. Then after that, transform the data. That is transforming the data is you are splitting the data and you are ranking it. Okay, given numbering, not the ranking, numbering. Based on the alphabetical order, we will give the numbering. After numbering, we are going to pass that data to the transformer, which will transform it, giving us the weightage. Okay, you will see that in the vector, it will be completely transformed. Then after that, you can give the data to your model. That's it, simple. Clear, guys? Let's do it one after the other, and data will be very huge. It's not just like that. Is the question. Based on your target, what is your target? Based on that, you will be getting the output. What is your target data is there? Based on that, you will be getting what is the category is there? Based on that, you will get. Now, let me do this one, guys. Any questions online? ठीक है? Now let's start it. Open करो. CMD. Now you know the process, guys. First, take a text file, any text file in the form of a list. That is, first sentence, take it as one sentence in the list, first element. Second sentence, take it as second sentence in the list, okay? As an element. Take a list, put it 3 sentences in the list. That's what I mean to say is. Maybe it's okay, guys, let's do it with a simple data, simple sample data we are going to do it. Then we can go with a big data. Now let me do this, guys. First, import pandas as ed, import numpy as np. Okay. Now I will create a data. I'll give it a name as text. Text is equals to. First, I will creating 3 text sentences. I want to do it. First one is welcome to Python data or Python class. Okay. Second one, I will give it as box. Okay. Third one is India. Any sentence you can take it, guys. Hyderabad city. Is there anything repeated over here? I is repeated. And welcome to Python class. And Python is oriented language. Oriented language, you can say. And okay, I live in city Hyderabad. Okay, just take this. Now this is my text, guys. Okay. You can take any text, not this. You can take any text, and then first thing we have done this. Next is what? I said the step count vectorizer from sklearn dot. There is something called as feature underscore extraction dot text import count vectorizer. Right? Count vectorizer. Now next step is create an object of count vectorizer. Cvec is equals to count vectorizer. Okay. Now you can see that there is a lot of the options are given over here for us. This all you can see it in the NLTK or all these things. What is this tokenizer? What is the stop word? And all these things we are going to see it in the NLTK. So here also you can perform all of them very clearly. Okay. Now I created the object. Cvec dot fit, and then what is that? text. I've done it. Now my CVEC object is learned from the data. Yes or no? Now what it will do it? It will split the data first and then it will rank the data. How to know that whether it is ranked or whether it is split or not? Now first is CVEC, or there is something called as get feature names. Now it will give me all the feature names over here. Let's see this. What is brown? Brown is over here. Brown dogs, brown. Then afterwards city is there based on alphabetical order. Dogs, Hyderabad, in, is. All these words are been split up. Okay, all these words have been split up over here. Yeah. Okay. So now after this, I want to see the ranking guys. So there is something called as CVEC dot price vocabulary. Now you see this. It gave the ranking. I mean, it says numbering of them. So here, the first one is given, 0 is given to brown. You see this? But we got the brown as a first. The 0 number is given to brown over here. Then followed by city. City is given as 1 over here. Then followed by class. Then 3 is dogs. And then Hyderabad. Now on what basis it is doing? It is on alphabetical order. Alphabetical order. You see this? Okay, clear guys? You have done it. Now we will transform this one. Got it. Now let's transform this. How to transform it? CVEC dot transform. CVEC dot transform. What do you want to transform? Text. And then we will give it as text CVEC. Data CVEX or CVEX. I will give it over here. Now text dot CVEC. I'll get a sparse matrix. I told you what is a sparse matrix? Huh? Imperial and navie. What is a sparse matrix, guys? मिल गया सर्च करो तो दिख रहा है यहाँ से पीछे से दिख रहा हूँ क्या हुआ what is sparse matrix see whenever a matrix is having a lot of numbers lot of zeros that will be considered as a sparse matrix now in this case there's a lot of it's like 3 into 17 is there right is 3 into 17 guys these rows each how many I gave it over here 3 see first one second one third one so 3 is there now what is 17 means 17 unique values are there words 17 unique words they are all considered as a columns okay now this one I want to see it means how I'll do it text underscore CVEC or 2 array if you the 2 array you are going to get it got it now in this the first one is what is the first word over here like CVEC dot get feature huh? Get feature name so when I do this I will get names now you see this okay guys observe this let me get to the other side Now observe this, guys. I got all this one in a single. Now observe this. This is the order I have it, all this one. Now I will take it this one. Now in this, let me increase the font. Now observe this. Now see, first one is referring to the brown. Second one is referring to the city. Third one is referring to the class and dog, like this, Hyderabad. And all these things are being given in this, each and every row, column is given like this, guys. All of them. Okay? Clear? Now, when you check it out, our words, like whatever the words we have taken over here, this first sentence, let's take the first one. Now, each sentence is this matrix. Remember that each sentence is this, whatever the array, number array is there, each sentence belongs to this. I can remove this one, I don't need this. Okay. Now, let me clear this one first. Hope it is clear now. See, first one is welcome. Here is the welcome, guys. Over here, the last. Now, because in the first sentence, this complete sentence, whatever is there, this first one belongs to this one. Okay. The welcome is there here last. Last, you got it one over here. Can you see it? One. Now, the first one belongs to what? Brown. Is there any brown inside this? No brown. No brown is there over here. Where is the brown? Brown is there in the second sentence. See, second one, you got a one over here. How you done the same way, like how you done the one hot encoding the same way. Wherever the value is there, that you will get it 1. Wherever the value is not there, they will get it as 0. Now here, the 2 is there. 2, 1 will be the second one. Then Python is there over here. Python in the first sentence, 2 times it is coming. See, welcome to the Python, and Python is oops language. So how many times the Python is? 2 times. That's why we got the 2. Now there is a part is there. The part is not there in the first sentence. Okay, that is there in the third sentence. That's why you got it over here. Can you see it? Like this, it is just splitting the whole sentence into a numerical way. Completely it is just it split data and it ranked the data and then arranged in a numerical, converted into numerical form. That is done with the your count vectorizer rule. Now comes the next one. What is the role? TF IDF transformer, not the vectorizer. We are having the transformer. Now, what we will be doing is, whatever we are getting the data, what is the data we are having here? CVEC. Now this I will forward it to from sklearn dot feature extraction dot text import. Again we have it TF IDF transformer. Okay. Now I will make it as TF ID is equals to TF IDF transformer. Okay. Again, this is having a lot of features will be there again, like norms, user IDF, smooth IDF, sublinear IDF, all these things. Okay. Now let me create this one. I created TF IDF ID dot fit. Let me do the transform also. Okay. Which data I have to fit and transform, guys? Text underscore cvec. Text underscore cvec. Now this I will take it as text underscore FID. Got it, guys? Text underscore FID. So you get a sparse matrix. Again, you see this. I was checking it out. Is there anything? Here, guys. See, the object is TF-ID, guys. In that, IDF is an attribute is there, which tells us the ranking of the birds. So this is like sometimes the rank will be low. It goes to the all of them are ranked equally over here. And how many are there total? 18, I think so, right? 18 in total. Index is 17. Index is 17, total 18 are there. All of them are given the equal ranking. Sometimes if there is any words are there, the, all those things is given as based on the sentence. Based on the sentence, the words will be ranked up and ranked down over there. And some of them are ignored also. Now you see I is being ignored. I is not given any importance over here. There's no I at all. Some of them they will ignore it. So now it is the ranking. Now you want to see the actual matrix, how it is gauged up. Dot to array. Now you see this. So whichever the now first one is this. First one is this. Okay. Now our matrix, if you take it over here, I will print it, then you will understand. CVEC dot text underscore CVEC dot array. You see this, guys? This is 0. 0 is given 0 over here. Then 0 is given 0 over here. Then it is 1. So here there is a weightage is given over here. Because all of them are given the same weightage because they are not interlinked. They are all separate one. If there is a very large data is there, they will interlink and the weightage will be going up and down over there. Okay? This is just to show you. We are not going to do them in a programmatically. Just to show you what is exactly is happening. So here, some weightage is given as 3.1. And some is given as, you see, 6.63. So which one is given 0.63 is Python. Python is given 6.3. And some of them are given 0.55. And like that, they are giving it. Okay. See, this is the way we will be teaching. Now, next one is you have to feed it to the model. That's it. You have to feed to the model. Then I don't have that dependent, independent kind of stuff. I can't feed it over here. Then we can see the original data. See the original data, guys? You want to practice this. बाकी लोग दे रहे हैं सुनो. What happened, guys? Want to do it from Input चले input numpy as np. So let's see the data, guys. There is something called as from sklearn dot, okay, from sklearn dot data sets import is what's the name of that, fetch, yeah, fetch 20 new groups, fetch 20 new groups, guys. Okay. Now this is what this is having is, okay, this will be having two sets of the data, two columns kind of stuff. One is the news. What is the news? Exact news. And then next side, it will be having the categorization of the news. What category the news belongs to. Okay. What category the news belongs to, that will be having over here. So if you see that the data, I'll give it as news underscore data is equals to fetch underscore 20. Now I will do this. I'll get the complete data, guys. It will take some time. Yeah, it's taking more time than expected. You are getting same problem? Because a lot of data will be there. Lot of text and same Vacheshinda. You got it? Anyone got it? All are waiting. Antena నీకు కూడా? This is the uses for the text classification. Text classification. Just give me 1 second, guys. Let me close it down. क्या एरर दे रहा? क्या मतलब? ऑब्जेक्ट नहीं बना रहे ना हम लोग, डेटा लेकर इसमें डाल रहे हो, एरर दे रहा है ये. क्या एरर है? मेमोरी, यूआरएल. बड़ा झंझट रहेगा. निकालो, डाउनलोड करो. हाँ, यही वाला करो. Got it? You got the data or got the error? Blendra. Okay, just go through that. It will be in the form of dictionary. Okay? Just go through that data. You will be having some training data, testing data over there. fetch 20 here. Got the rate. Data. Close చేయండి. క్లోజ్ చేసి మళ్ళీ స్టార్ట్ చేసి న్యూ దాంట్లో మళ్ళీ ట్రై చేయండి. Got it? आ गया? Huh? Okay, just open that one. News underscore data. आगे వచ్చేదా ఈ అమ్మాయిలు కొంచెం కూడా ఆగరు. हाँ, उसके अंदर ये वेरिएबल डालो ना, फिर उसके बाद वेरिएबल डाल के डाल दो, आ जाएगा. Now here you see this guys. आ गया? So this is actually two parts will be there inside this. Yeah. Huh? అది క్లోజ్ చేసేయి, మొత్తం క్లోజ్ చేసి కొత్తగా ఓపెన్ చేసి తీసుకో. मिल गया सबको? Got it? Closing. What you are closing? उसे वो पर्टिकुलर पेज को क्लोज कर दो, फिर दूसरा वाला ओपन करके फिर शुरू करो. एंड विदाउट गिविंग द वेरिएबल फर्स्ट फेच द डेटा. बगैर वेरिएबल दिए फेच करो, फिर उसके बाद वेरिएबल में असाइन कर लो. మీకు డేటా వచ్చేసిందా? మరి సబ్కో ట్రై చేశారా? వేరియబుల్ ఇవ్వకుండా ప్రైస్ చేయొచ్చు. ఇది ఇప్పుడు ఇది ఉంది కదా, దిస్ గివింగ్ ద వేరియబుల్ इफ यू आर नॉट गेटिंग मिल गया, शुरू करो. फिर क्या देख रहे हो? fetch with the fetch only this one and try it out. Now next one guys, see this, most important is news underscore data. You see this one, we are getting the same one, but keys, because this is in the dictionary format. I told you the most of the times you will be getting the data in the dictionary format. So now you see this. So in this, what you have to understand is data is the one which is more important for us. Okay, and then there is something called as files, file names, and then target names and target. Target names and target. Now what you have to do it is inside this. Now I will say that fetch. Inside this there will be something called as subset over here. Fetch 20. In the fetch 20 will be a subset. And processing. You closed it completely. ఏది మీరు కొలాబ్ వాడుతున్నారా? కొలాబా జూపిటర్ నోట్బుక్? రైట్ అవుట్ మళ్ళీ చూడండి ఒకసారి. జస్ట్ see this guys. सजी आ गया तो ये देखो ना फिर. ठीक है. Now go to the sub 20 groups guys. In this there is something called as subset. This subset you have to give it as train. This will give you the training data. No need to worry about it. It will give you the training data. Okay, and यहाँ पर और एक रहेगा categories. What is the categories is names of the training data. Names of the training. Usually the target names will be there over here. That will be coming over here. Let me show you the target names. You will understand much better. Okay. Okay, sorry. हाँ ठीक है फायदा क्या है एरर आ रहा ना वहां पे news underscore data dot how you deal with the dictionary the same way. Here you say the target names. Oh, see this data, guys. Try to understand. This is the data. This is already having a training data and testing data inside this. No need to worry about that. Okay. Now then there is a target names and target is there. What do you understand by target and target names? हाँ वो तो मालूम है टारगेट नेम्स और टारगेट में डिफरेंस क्या है हाँ कॉलम नेम है नेम्स है कितने नेम्स रहेंगे टारगेट को फिर यहाँ पर देखो नेम्स क्यों दिया हुआ ठीक है देखेंगे कितने आएंगे कितने सारे कॉलम्स है सी जब तक target and dependent data actually dependent data inside the values in that target column the values will be there right अब देखो हाँ like Irish data is there Irish data के अंदर if you go to the target they gave it as 1 2 3 0 1 2 0 stands for Setosa right like that value what is that 0 stands that is what it is given over okay? Inside the target there will be numbers will be given usually it will numbering will be given that number what that exactly mean it is given 0 is this one 2 1 is this one 2 is this one like this these are the names okay these are the names no already it is there no need to convert it यहाँ पर है target में यहाँ पर देखो तो टारगेट में वो मिल जाएगा न्यूज for data I'll give it as target you see this I got the data or number okay now if you want to see the size 13314 hai these many records are having only these values are repeated in that. Okay records are so many but the type of values are these okay? Now in these categories I will give you this one I will give you the target इनको बिठाएंगे यहाँ पर लेकर okay now this subset is the train okay now categories is nothing but the target names okay target names and this one I will give the name as train data news underscore train right guys क्या हुआ दिक्कत क्या है भाई डेटा लेने में इतना दिक्कत है तो करने में कितना होगा आपका एंड अगर ये डेटा इफ यू गेट इट फ्रॉम द वो भाई साहब बोल रहे थे डाउनलोड करके करेंगे बोल के तो it will be very difficult to upload because multiple folders you are going to get and वो folders में हम लोग choose करना पड़ेगा कौन सा क्या है इसलिए मैं am taking that directly online so it is very difficult to do it so if you do this I will get the news train now news underscore train dot shape I will do it what is this oh it's a dictionary sorry keys for the keys okay now next one is we are going to take the testing data. News test. Test. And here I will give it as, here you give it as test, guys. Got that news underscore test dot keys. Okay, you got the training data and testing data. Got it, guys? Clear? Now start your count vectorization. Start your transformation. Play karo. Just play with it, and we will stop it. वो लोग rolling here. थोड़े पुकार ले रहे. So you got the training data and testing data, guys. First is take all the training data. Training data has to be done the count vectorization and do the transformation and then give to the model. Okay, you know that. Okay, then when you are giving to the model, you give the target over there. Target, not the target names. You have to give the target. You understood what I'm saying? It. See, this is your training data. Training data ko training data. Isme data. This is the one. This one you convert it into count vector. Give it to the count vector. How you give it? News underscore train of data. This is the one you are going to give it to the count vector. Count vectorizer. You will going to give it. Then after that, this will be transformed and split up, and it will be transformed. And please don't open it and don't print it, or don't try to see that. Just see the shape, because if you are trying to see that whole data in the form of 2 array, then your system get hanged, because it's a very high-end data, very huge. So never convert that one into 2 array. When you get the sparse, right? Sparse array, don't convert it into 2 array, because your system get hanged up, because it's a very big data. And our systems are not so flexible to do it. Okay, so just see the shape. Clear, guys? Okay, we will continue it tomorrow with this, and I will try to get one more, and we will do it one more also. समझ में आ गया क्या करना है? ऐसा कैसा आएगा 25? हाँ, ऐसा कैसा आएगा 25? This data shape is equals to list. Import. Yeah. Now this data you convert it. First you create an object. Cvec is equals to count vectorizer, and then this one you fit it. Cvec dot fit. It's taking some time. Maybe how much time it will take. It's done. Now Cvec transform news train data over here. Okay. And this one is news train dot Cvec. News train underscore Cvec. If you give it, ये क्या शेप दिख रहा है ना यहाँ पे वाला. Please don't convert it to array. इससे बोले 5 ही आ रहे हैं. बढ़िया. अरे मैं मत करना, हैंग हो जाएगा। कर रहे क्या? कर दिए? नहीं हुआ? वो हो जाएगा, देखो तो, मत करना वो। इट इज अ वेरी ह्यूज डेटा। So all you have to do it is check this one, guys, and this one you give it to your transformer. आ गया? बांध दिए? करने का इरादा नहीं है? दिख गया? ठीक है फिर इसके बाद ट्रांसफॉर्म कर दो। चलो गाइस, आई विल स्टॉप इट ओवर हियर। मेक टारगेट नेम इज अ कॉलम लेबल नेम। नहीं यार, कॉलम टारगेट का जो वन, यूजुअली द टारगेट कॉलम विल बी कन्वर्टेड इनटू न्यूमेरिकल वैल्यूज, राइट? वो न्यूमेरिकल वैल्यू का मतलब क्या है वो बता रहा है वो। 1 2 3 4 5 वो मतलब बता रहा है क्या है वो। ठीक है? So guys, I will stop it over here. We'll meet tomorrow continuing with this again.